Hi, my name is Dario, and welcome to this session, the Hitchhiker's Guide to Multi-Tenancy and Self-Service Civo Kubernetes Clusters. Really long title. So, today I'm here with Saim, but he's missing. I don't know where is he, but unfortunately he had some personal issues, so that's the point. That's the reason why he's not here. Anyway, my name is Dario. The surname is always butchered, especially by British and American people. That's okay. Tranchitella. Everybody says Tranchitella, but that's part of the game, not a big problem. And I'm doing technical advisorship, also known as CTO at Clastix. Clastix is a startup based in Italy, the country where I'm coming from, and we're doing Kubernetes Multi-Tenancy. Saim instead is CNCF ambassador, is contributing to Paralus, and today we would like to talk about Paralus, Capsule, Civo, and multi-tenancy. And I would like to start with this story, this tale, a broken developer's tale. So you can imagine that I got an application, and this must be onboarded on Kubernetes. So how can you do that? You have to open a Jira ticket. I saw this madness about the Jira tickets where you have to open this ticket asking, please provide me the namespaces, all the required components to run, and so on and so forth. And essentially, we are creating a blocker. So it means that you need to wait for the ops to create the environment. And the environment could be a namespace, or it could be a Kubernetes cluster. So it means that essentially the SRE, or rather the ops people, is creating all the required components. And this means that essentially we are breaking the you build it, you run it principle. Because, in DevOps principle, it means that you are creating your applications and you're running your applications. But we know that in reality, it's much more way complicated. And then you have to repeat this bad tail, for every application and every environment. So it means that we are creating so many noises with the communication between the dev and the ops team. And furthermore, you need to solve and to tackle some challenges like the governance, resources, and policies. You can achieve that with automation, but it really varies about your organization. So how can we solve this one? Keep in mind, I'm an expert, according to me. But it means that if you talk with a lot of people, they say, well, what you can do is to create one cluster per each tenant. So it means that each developer is managing their own clusters. And I'd say it's legit, it can work, but it may vary according to your governance issues. And also, having multiple clusters means that the organization is going to face more cost. And furthermore, who's going to manage those control planes, those clusters? Because developers, I don't want to run against developers, because I've been a developer and we are just focusing on applications. We don't want to focus on Kubernetes. So what you have to do in these organizations is to say, we can solve the multi-tenancy dilemma using multiple clusters, or rather we can try to use a shard cluster. But using a shard cluster is really painful, because although with Kubernetes we got namespaces, we know that namespaces are perfect to isolate applications. And we can try to say, okay, one namespace is a tenant, but we know that in reality, developers, they need multiple namespaces for organizing applications or for other requirements. So, furthermore, there is the issue of the cluster sprawl phenomenon. So, keep in mind that the cluster sprawl is a word that has been originated by the city sprawl, where it's pretty popular in America, not the same in Italy, but in America essentially you have these buildings, a lot of people living there, and you are creating more and more homes, more houses. And in the end, you're ending up with this neighborhood that is unmanageable. And same applies also to Kubernetes clusters. So the more clusters you have, the more operations you have. You can try to solve that using the cattle approach. So each cluster is essentially cattle, as we were doing with containers. But we know that in the operation standpoint is not the same because we got the alerts, we got the upgrade and rolling out of new features to the clusters. So essentially, it's really painful. You can do that manually, but it's pretty impossible. You can try to automate that, but it's really, really challenging. Furthermore, shameless self-promotion. I've been selected in 2021 for KubeCon. Unfortunately, it was virtual edition, so I wasn't there in real life. Anyway, with Wargaming, that is one of the first adopter of Capsule, we were able to demonstrate how Wargaming was able to save up to 70% of their worldwide clusters using Capsule. So we solved the clusters problem. How can we fix that? Because that was our first question. And we can try to fix that with multi-tenancy because in the end this talks about multi-tenancy. And multi-tenancy essentially is a way to have multiple tenants. And keep in mind that tenant can be a team, a department, your organization. And the idea behind multi-tenancy is to create a single entry point for your organization and optimizing costs, because we are always talking about cost, especially during this time. We want to save resources, and multi-tenancy is a game changer. When I talk with people during meetups, conferences, and so on and so forth, what I try to explain is that your cluster is like a building. And in this building, you have multiple apartments, and these apartments can be rented to tenants. And what you have to do, obviously, is to create walls and to create isolations between the tenants. Otherwise, you can imagine having one tenant that is listening, I don't know, heavy metal music or black metal music, and you get, oh my gosh, I'm totally pissed off about that. Yeah, the same applies also with Kubernetes with the noisy neighbor effect. So, as I said before, multi-tenancy is really challenging. It can solve a lot of issues, but in practical, is really challenging. Also because you have to play with RBAC, since you want to avoid that the tenant A is able to create, edit, or delete resources in tenant B and vice versa. So it means that you have to be sure that the RBAC is well designed. And furthermore, you have to secure the kubectl access. So you cannot use just a single kubeconfig for the whole organization saying, developers, please behave correctly. It doesn't work that way, okay? And furthermore, we were talking about noisy neighbors. I met a lot of noisy neighbors back in the day, but the same applies also with Kubernetes. The issue with Kubernetes is that it's software-defined everything. We got software-defined storage, software-defined networks, software-defined workloads. Because we got the nodes that are essentially kubelets running workloads. And on a node, I can have multiple applications from different tenants. And what happens if I have this application that is consuming all the CPU throttling? My application is going to be put in the queue of the CPU cycles. Or the same applies also with network. So you can imagine having, I don't know, 20 megabit connection, and this application is consuming all the bandwidth. My application there, or at least one of the replicas of my application, is going to suffer from the bandwidth limitation. And also, you need to create a sort of you need to collect all the metrics to understand how the cluster, well, how the tenant is consuming the resources. Because in the end, you are using multi-tenancy to optimize resources, but at the same time, you would like also to know more how many money a tenant is consuming. So, you can imagine this in a single cluster, and I'm not saying that, oh, you need to have one huge cluster with multi-tenancy, end of the story, because that will be a sort of single point of failure. And I know that in the end, multi-cluster management is still a thing, because maybe you have regional clusters, or maybe you have different premises, so you have data center 1, 2, or even different cloud providers. But you can imagine trying to replicate these for one cluster and replicate all these behaviors across multiple clusters. You can do that. I'm not saying that it's possible, but it's really, really challenging. Otherwise, I won't be here talking about multi-tenancy. So let's try to solve the developer's tale. So fixed developer state is something like this. So the ops team or the site reliability engineering team onboards the tenant. So what does it mean? Essentially, it means that we need to create a sort of abstraction of the tenant, and we define the users. Because when we talk about multi-tenancy, we are always talking about resources, and then we are talking also about people. So the tenant owners, you can call them, how would you like to call them? Tenant owners, users, customers, is the same. In the end, we got resources, we got users, and we need to assign these resources to the tenant owners. And then finally, you can onboard your application on Kubernetes and you can create your own namespaces. But creating namespaces is really challenging because I can create a namespace, but how can I get granted RBAC access just to my own namespaces? Unfortunately, this is not possible with native Kubernetes. So there must be a sort of automation, and also this automation must be always performed with a reconciliation, because what's going to happen if I delete my role binding in my namespace? You know, it's like locking out of the apartment. And finally, once you have everything automated, what you can do is to adopt multi-tenancy, and multi-tenancy through the application delivery manifesto. So in CNCF, there is a this tag that is named app delivery, and they are focusing on multi-tenancy because you can imagine I'm a developer. I would like to deploy my own applications in the clusters, and I want to be sure that the application is always up and running, and maybe what you have, what you would like to get is also a sort of abstraction of the underlying infrastructure. You don't want to focus on nodes, cluster role bindings, CRDs. You got just your application, and it must be shipped to production. So what you can do is to use a GitOps approach, and it works very well. I'm not saying that you have always to do that. I met so many organizations, they are not using GitOps, but you know, it's pretty standard. Everybody is able to understand that. And with GitOps, essentially you define your application. The application is deployed across all the environments and all the clusters. So let's try to talk more about the real operations. So I would like to introduce you Paralus, that is offering a controlled access. So I'm not the maintainer of Paralus. I'm just using as a sort of end user. So I hope that same reviewing this recording doesn't get upset about it. So it's open source, and that's great during this time. So it's Apache licensed. And essentially, what I really love about Paralus, and I'm speaking not as a maintainer because I'm not a maintainer, is that essentially with Paralus you can access the cluster with an identity provider connected to your cluster. So you can imagine having a Kubernetes cluster. I cannot edit the API server settings like the identity provider, and I want to connect my GitHub organization, my GitLab organization, because I don't want to create service accounts every time for a new member that is onboarding the cluster. So I want to create a sort of connection between my organization on GitHub or even on GitLab with the Kubernetes cluster. And using groups, I can say you're part of this, you're a member of this group, and you can access these clusters. And furthermore, what I like to have is also a graphic user interface. You know, all the people, they really love the UI. I'm a nerd guy, I love the CLI, but it's just me. But having also this UI for developers, especially for those ones that are not so familiar with Kubernetes, is really, really helpful. And furthermore, with Paralus, you can also distribute RBAC, and that's great. Because with Paralus, you can manage a fleet of Kubernetes clusters and distribute a sort of namespaces, well, to their namespaces to these clusters, along with the RBAC assigned to these users or set of users. And there is also a nice feature that I really love, that is also the audit log of all the kubectl actions issued by the users. So essentially you have this single entry point that could be really helpful to have all the history of the developer's actions. So this is how it works. We got the Paralus server, and is sitting in a sort of bastion mode to the clusters. And what you can do is to use the kubectl CLI. So Paralus is providing you a kubeconfig, or rather you can use the kubectl through Google Chrome or the browser. And essentially you're connecting to the Paralus server. That could be an HTTPS secure connection. And in Paralus, essentially, you got all the authorization because you're connecting to the identity provider. So there is a sort of this OAuth integration. And once you got authenticated with Paralus, thanks to the kube context, you can connect to the underlying, to the downstream clusters. And there is a just-in-time provisioning of the service account with the required RBAC. And essentially, you're always acting on behalf of Paralus with your own rights. And that's great because the most critical thing about Kubernetes is that what's happened if you need to offboard a tenant. You know, when you need to onboard a new developer, a new access, it's pretty straightforward. You create a service account. But what happens if you want to revoke access? You have to create maybe an automation, and it's going to take some time. Or you can imagine if I'm using a service account, I need to revoke the service account. It's really painful. You have to create your own automation. Essentially with Paralus, you can do that, and you can distribute that to a fleet of clusters. Having a single cluster is okay. When you have a fleet of clusters, you can imagine you have to repeat that action multiple times. Instead, with Paralus single entry point, everything is distributed. So, how can you use Paralus? Essentially, as I said before, you can have Paralus as a sort of bastionos to access all the clusters in a centralized way. You got also the audit log that is really, really helpful, especially if you're working with enterprise companies, enterprise users that are always looking for audit. I want to know who, sorry for the bad word, fucked up production. Yeah. You can get it. And furthermore, you got the just-in-time service accounts with the federation and the RBAC, and that's really, really helpful. But then, since we are talking about identifying the users, we need also to address multi-tenancy. Keep in mind that there is a sort of overlap between Paralus and Capsule about multi-tenancy. And now I can talk about the first open source project that I developed during 2020 during the pandemic, and it's Capsule. And Capsule, essentially, it's a framework to build multi-tenancy. So, also this one is open source, Apache 2. We are donating the project to the CNCF in the incubating state. We are creating all the due diligence document. And what I really love about Capsule is that it's my project. No, essentially, I try to design that as a sort of framework, okay? I always want to provide a way to get something done in a non-opinionated way. So it's not a product, but rather what you can do is to use that to build your own multi-tenancy implementation. I always say that there are 50 shades of multi-tenancy in Kubernetes because somebody is saying, okay, I need just a low-level multi-tenancy. I want to group namespaces together and automating the onboard and the offboard processes. So when I delete the tenant, all the namespace, they must be removed. Others instead are using multi-tenancy in a middle field implementation, so they need to ensure, for example, that you cannot use load balancer services. Others instead are using multi-tenancy to offer CaaS, so container as a service. So you need to be sure that all the containers are running in non-privileged mode. You have to ensure that the pod priority class assigned to the pods in the tenant are not colliding with the higher one. I remember it's always higher or lower. Yeah, the higher priority. So essentially, you can achieve multi-tenancy in different way, and with Capsule, essentially, I think that it's a framework. I'm a bit biased about that, but you can achieve that. How does it work, essentially? When I try to explain how Capsule works, I always talk about mutating admission webhooks, CRDs, and identifying the users. And I don't know if we have June's fun here, but you can notice the nice GIF where you can see Harkonnen and Atreides. So if you are a Dunes fan, I hope that you enjoy that. Anyway, what we do is to identify the users because essentially with multi-tenancy, users must be logged to the cluster, and we check if the user has a tenant assigned. And starting from there, we know if that user can create some pods in specific namespaces, if the pods can run with a specific pod priority or runtime class, or if I can use some ingress class or storage class, and so on and so forth. So in the end, it's a framework that is creating, that is leveraging on namespaces. So we are not doing virtual clusters. Our idea is always to have a single entry point. So essentially with multi-tenancy, it's really important if you are embracing platform engineering. I know platform engineering right now, it sounds like a buzzword, a huge hype, but essentially what you need to do with multi-tenancy and with platform engineering is to abstract all the required underlying implementations to ensure that the platform and Kubernetes cluster is always up and run with a real quality of service according to the applications on board and on top of that. So now, finally, after so many words, we can try to understand how it works. And I did a demo, and I was brave enough to do that in real life, so I recorded that, and it's working, luckily. And obviously, if you have any question, we're going to have the Q&A session at the end. Otherwise, stop me, and we can talk about that. So, let me see. Oh no. It should work like this way. I got all the chapters. And obviously, we are talking about Civo. And as you can see here, I'm creating the cluster. And it's Civo Navigator Europe 2023. And what you can do is to install also Paralus using the marketplace. We got also the slides explaining that in the end. But just to share that Paralus is working mostly on any Kubernetes version as well as Capsule, so we don't have any huge constraint. Obviously, I would suggest you running on starting from 120 mostly because it's one of the latest supported also by the community. And here we just need to wait for the cluster for being provisioned, and obviously keep in mind that Capsule is able to work in the cloud like Civo, but also on-prem as well as Paralus. So once the cluster has been created, what you have to do is to download the kubectl, the admin kubectl. And it's required because you need to install some add-ons. So once you got it downloaded, what you can do is to export this kubectl and finally ensure that everything is up and running. And you see here that it's a plain Kubernetes cluster. And now what you can do is to install Paralus. So how can you install Paralus? Essentially, you can install that using the Helm chart. And as you can see here, I'm using the dev generic environment options. Well, the value for the dev environment, because it was much easier. There are not plenty, but Paralus, it has multiple components that are combining together. So with the dev generic, it was much easier. So we need to be sure that Paralus is up and running, and it takes some time. So I'll skip here, and keep in mind that once we got Paralus up and running, so the relay server, FluentBit, Contour, PostgreSQL, and all the dashboard pods, what you can do is to extract the service load balancer IP. As you can see here, we got Paralus, Contour, Envoy, and this is the external IP. Why that? Because we are going to see that essentially there will be a sort of OAuth2 shake between the identity and the Kubernetes cluster, so we need a valid IP endpoint, a valid application endpoint, a fully qualified domain name to connect. So once we got it, what we have to do is to ensure that the DNS are propagated. So as you can see here, I did a typo and I was recording the wrong, this is the correct one. So I'm going to expose the Paralus console using console Paralus Clastix IO. That's the entry point for the cluster. And furthermore, we have also to be sure that's the IP is the same, and it was the same. I was using 101, so 87, 87. So we are there. So once we are there, we have to extract the admin password because everything is done using the UI, and what you can do is to specify a password or otherwise extract that from the Paralus logs. These kubectl logs blah 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 is extracted by the helm install, so I just need to copy paste, and as you can see here we got our password that must be used for the first login. So once we have done that, we have to reset the password. So I'm accessing console Paralus Clastix IO, and I can access with admin Paralus local with the password, and obviously since it's just a one-shot password, I can reset that. Okay. So as you can see here, we got our projects. So the Paralus projects are a way to collect multiple clusters because Paralus is not expecting to run just on a single cluster, but you can create multiple projects and grant different access to developers to different clusters using a single and unified kubeconfig. So for our use case, instead, we're going to use just a single cluster on Civo, but it really depends. You can use multiple clusters. Just for the sake of simplicity, I was using this one. And I'm going to create this project named Civo Navigate Europe 2023. And there is a typo here because I need to register the Civo cluster. So remember that I installed Paralus in the Civo Navigate cluster, and this is just Paralus, but now I have to register the cluster. So we are going to have a 101, so Paralus host on the workload cluster. What you can have is a public cluster that is then connecting to private clusters. For the sake of simplicity, I was just using 101 mapping. So once you got the cluster registered in Paralus, you are going to get also a Bootstrap YAML. This Bootstrap YAML has been downloaded in my downloads folder, and using the admin kubeconfig, I'm going to install this agent. So it's the relay agent that is going to be connected to Paralus. And as you can see here, the registration has been completed, and the cluster has been successfully assigned to this project. And now what we have to do is to connect the identity providers. So this should be the right one, yeah. So accessing in system, what we can do is to access the identity providers, and keep in mind that you can connect multiple identity providers. Just for the sake of simplicity, I was using GitHub because I'm the owner of the GitHub Clastix organization. That's the point. So you have to use the client ID, the client secret, and so on and so forth. Keep in mind that Paralus has the documentation, is very well written, so you just need to follow all the steps one by one. And as you can see here, I already created in advance an application on GitHub because I needed the secret access key and the access key. Once we got it, obviously, we need also the callback URL that is required for the OAuth sharing, and we are going to update that in the application of GitHub. And we are done with that. So now what we have to do is to connect to the cluster as a user, because right now we always operated from the admin standpoint. So we got the administrator, and the administrator is creating the platform. So now we have to mimic tenant users. So I'm creating an incognito window, and I'm going to log in using GitHub. And here, finally, I can use my GitHub account. So it's Promethean is my nickname, and I access with my password, and obviously with the two-factor authentication. And when I do that, you will notice that essentially we are going to be redirect to the console of Paralus, but we don't have any access because this is required as a sort of onboard. So we created the user, and this user is going to be mapped into the console. So Switching back to the admin view, you can see that we got the users, the local users, but also the identity provider users. So I've been successfully connected to Paralus, but obviously I don't have any access. So what we have to do is to connect a second time, because for multi-tenancy, I want to simulate two users that are part of two different organizations, but they are sharing the same cluster. So we need to add a second user, and this time the user is going to be Alice. I using Alice because it's always the user name that we are using during our capsule end-to-end testing. So I'm authorizing the application, and once we are going to be redirect here from the admin, we see that in the IDP users we have Dario, and then we have Alice. Obviously, we have a different email address. So two users that are slightly different. So now that we got the users, we need to create the tenant role. So keep in mind that Paralus is offering a way to distribute the RBAC, and Paralus is coming with some roles, already predefined roles, or what you can do is to create a tenant owner role. This is required because Capsule is going to be sure that all the RBAC is managed by the tenant definition. So as you can see here, with Paralus we got some verbs on the resources. And what we need to do is to grant permission, mostly read permissions, to the project, the kubeconfig, partner, organization, user, kubectl, cluster read, and cluster read. So once we got this tenant owner role, finally what we can do is to assign users to the projects. So we access the assigned users, and finally we pick our users saying, please, you need to be mapped using the tenant owner role. And we are going to do that both for Dario and Alice. Now, what I can do is to access back as a Dario in the console. So I'll sign in with GitHub, and you will notice that finally we are going to have access to this cluster. Keep in mind that Paralus is exposing also some APIs, so you don't need to do the ClickOps here, but you can automate everything. But I just want to be sure that now I can see my project, and I can download the kubeconfig here. So I'm downloading this kubeconfig, and this kubeconfig, keep in mind that is not connecting directly to the downstream cluster, but rather is connecting to Paralus that is forwarding requests on my behalf to the cluster. So keep in mind that now I'm using Tmax here. I really love that, by the way. And in the upper pane, I'm the admin, and in the lower one instead, I'm the tenant owner, one of the tenant owners. And I'm going to expose the kubeconfig. So this is the kubeconfig that I exported, and I'm just checking that everything is working. And as you can see here, I'm not connecting to a different cluster, but here, even if I issue kubectl version, I'm connecting to the downstream cluster, to the project cluster. There are some boundary context terms here, but I hope that you can follow anything. Now, since we talk about multi-tenancy, we need to be sure that this user is entitled to create namespaces. And I want to avoid that. Why that? Because we need some rules. You see here that I'm Dario, and I'm trying to create a namespace, but I cannot do that. Why that? Because we have to avoid to create namespaces to people that is not entitled to. That's the concept of multi-tenancy. I can enter in a house, in a flat, only if I have the keys and I got the entitlement. So we are missing the entitlement here. And furthermore, please notice also the service account. So all the service accounts are stored in the Paralus system. In fact, if I issue Kubernetes Paralus system, also this is a nice UI. You see here that we got this service account. keep in mind that the service account name for the users is always replicated in a predictable way. So it's not using random IDs and so on and so forth. So Dario performed his access in the cluster, and what we need to do now is also do the same for Alice. So now I'm creating a new window. I'm connecting as Alice with the password, and I can download the kubeconfig from Paralus. Okay, now I can export the kubeconfig. Please notice here that we got just 3 service accounts. And now we can imagine that maybe Alice is working in a different organization. So the first organization was solar energy, and the second one is wind. And obviously we are getting the same error because we got multi-tenancy applied here. And we cannot create namespaces because Paralus is just granting some read permissions on the cluster. So you see here that we got the name, and if I issue again kubectl get service accounts, now we got the just-in-time service account created. So what we have to do, we need to install the capsule. Should be this one. Yes, we are going to install Capsule. So how can I install Capsule? Essentially, we are using Helm. I strongly suggest using Helm because it's much easier trying to optimize, well, not optimize, but rather setting all the settings. So no resources at all, and I'm defining some Capsule user groups. So keep in mind that with Capsule, you can identify the users using users itself, so users that are identifying using the identity provider offered by the API server. You can identify users using the certificates, the client certificates, or otherwise even service accounts, because if you think about service accounts, they are regular users with a JWT, with a JSON Web Token with all the data. So I'm saying, please, all the Capsule users that must be entitled with multi-tenancy are service accounts in the Paralus system, and you can specify multiple groups. So it's not just one group. And essentially, when you launch this one, this command, we are going to get Capsule installed in the Capsule system, and it's going to take some time because we are generating a certificate authority, because Capsule is totally is built on top of the dynamic admission controls. So we got the validating and mutating webhooks. We are going to see that. So finally, Capsule has been installed. It was pretty quick. And now we see that essentially Capsule created some CRDs. I want just to focus on the tenant one. You see here, because we got the Capsule configuration, we got the tenant resources and global tenant resources. So it's a sort of framework to build something more extreme than just bare namespace as a service in Kubernetes. But now, what I need to do is to onboard the tenant. So if you remember, I was saying that we are playing our role game here. We got Dario and Alice, and they're working in the same organization, but in different departments. And we got the solar department here. And the solar department has some constraints. For example, we are saying that it has some owners, and you see here service account with the name. And in Solar, we can just create 3 namespaces, and we assign some limit ranges and resource quota. As well, we need to be sure that the Solar workloads cannot create noises against any other workloads in the cluster, so network policies. So now what I have to do is to create this tenant, and you see here that the tenant has been created, Solar. And now I can export again my workload, my kubeconfig for Dario. And Dario now can check if you can create namespaces, and the answer is yes, because Capsule is providing the role binding, the cluster role binding to the tenant owners. That was part of the user groups during the Capsule installation. And if I issue kubectl create namespace solar development, the namespace has been created. And what I can do is to create multiple namespaces. So solar development, I can create solar staging, yes. But my bad. I just want to show here that I created a namespace. And if you remember, in the tenant definition, we define the limit range, the resource quota, the network policies. And every time you create a new namespace, these objects are going to be placed inside of all the namespaces of the tenant. So we got the limit range, the resource quota, as well as the network policies. That's pretty important, network policy. So now, finally, I can create multiple namespaces. And remember, we had just a quota of 3 namespaces. So we got solar, development, staging, production. Let's see what's going to happen if I got an overflow. And the answer is that I cannot, because I exceeded my quota. So this is the multi-tenancy in Kubernetes. So now, let's see what's going to happen, because I want to create some deployments. So if you remember, I specified a resource quota. And the resource quota is pretty important here, because you can imagine if I have my cluster, I got my workload, I got my nodes, and essentially I can consume all the resources on those nodes. But if you're sharing nodes together with other tenants instead, it's much more complicated, because everything is software defined and all the workloads are running together. And Kubernetes is offering the resource quota API, and the resource quota API is really helpful because you can specify limits about the storage, the CPU, the memory, and even resources in the namespace. But that's the problem, just at the namespace level. Instead, with Capsule and with the multi-tenancy, we could have multiple namespaces. So how can we overcome that? And essentially, Capsule is overcoming that with a nice algorithm of distribution of the resources. So we have 3 namespaces and 9 pods available to run in my tenant. And as you can see here in the development environment, solar development, I'm creating 5 Nginx pods. And now what I need to do is to run also other workloads in the other namespaces. And I don't want to have an even distribution, so 3, 3, 3, but rather I can have 5, 3, 1 for a global overall of 9 pods, or maybe 8, 1, 0. So what I would like to share with you is essentially that we cannot say the tenants, please, you have to obey these rules. We are just providing you the resource quota, and you can distribute the workloads in your namespaces as you want, because otherwise I have to open a ticket saying, I need to change my resource quota. So now you see here that we are in deployment, in the production environment, and we created all the pods. And let's say I created 9 Nginx pods, so my quota is exhausted. What's going to happen if I create a Redis? So deployment has been created, but obviously I don't have any replica. In fact, if I issue kubectl get replica set, you see here that there is 1 desired but 0 ready. And if I describe this replica set, besides the typo, kubectl, come on Dario. Okay, describe replica set, you see here that we got the exhaustion of the quota, because Capsule is constantly reconciling the resource quota in the tenant level. So we are making resource quota tenant aware and not just limited to namespaces. It's like having your slice of a Kubernetes cluster. And furthermore, also, as you can see here, we got the network policies. And network policies are pretty important because you need to be sure that you're not creating noises to other services. It's a sort of denial of service. What's going to happen if I issue always calls against other services? I'm exhausting the bandwidth, and at the same time I'm creating also outages to other services. You can do that with network policies. But the issue with network policies is that you can delete that. So what's happened if Dario, that is a naughty boy, tries to delete the network policy? Capsule is intercepting the request and saying, I'm sorry, you can do that, because network policy is pretty important for your multi-tenancy, and you cannot do that. Now let's try to change the subject of our role game, and let's try to use instead the kubeconfig for Alice. So Dario Civo at Clastix.io. So now, again, if Alice tries to create a namespace here, should be this one, yes. Create namespace, Wind development. It doesn't work because Capsule is expecting a one-on-one mapping or one-to-many developers mapping between the tenant and the tenant owners. So we have the service account. You see here it has been created before at the first login. And what we need to do is to create this tenant. So this tenant is named Wind, and I'm going to change the subject. So keep in mind that here you can specify service account, users, or even groups. Now I can create the tenant, Wind. And what I can do is to issue kubectl get tenant. So essentially keep in mind that with kubectl get tenant, you get the list of all the tenants. And obviously, tenants, they are not residing at the namespace level, but rather they are cluster scope resources because we are creating a next level, well, not a next level, but it's a cluster scope resources because we are collecting namespaces together. And also for Wind, we got a quota of 3 namespaces. But what I would like to show you is that essentially, if now I create the namespaces as Alice, I got automatically a bump in the Solr definition. So the namespace count is getting increased. And we are doing that because essentially we are running Capsule using webhooks and using all the operator patterns. So every time there is an edit, a change in the objects, we are going to get notified. And furthermore, using the webhooks, we can change the behavior of some HTTP calls. For example, if Alice tries to create an overflow namespace, so exceeding her quota, essentially we can block that. It's a feature offered by Kubernetes itself, and what we're doing with Capsule essentially is just trying to play in a more smarter way with all the machinery offered by Kubernetes. So you see here that we always use kubectl, so we are not using any third-party plugin. It can work on any Kubernetes cluster distribution, and essentially you can do more and more stuff. Keep in mind that Capsule has a website, Capsule Clastix.io, where we got plenty of recipes here. So creating space, pod runtime classes, so a lot of stuff. But obviously, if you have any question, I'm really happy to answer that. And switching back to the slides, we should be here. Yes, it's demo time. So keep in mind that Paralus is available in the Civo marketplace. So what you can do is to avoid using the ham install madness. And when you create the cluster, you just need to access in the security section of the marketplace and selecting their Paralus. It's here.